Okay, I think that now everyone is muted. Also, in our last class lectures, we have discussed different types of power plant. Okay, so from today we will, please don't draw. Why anyone is drawing? So in the last class we have discussed in the different types of power plant. So today we will discuss steam power plant, and today I will use this drawing to make you more understand more properly. So steam turbine power plant and how steam turbine power plant works we'll discuss today. Okay, so this is our main topic of today. So you can see a schematic diagram. Let me clear that drawing. A schematic diagram. This is basically the schematic diagram of a steam turbine power plant. So always remember there are four main parts. There are four main parts of a steam power plant. The first one is boiler. The first one is boiler. I'm writing and also recording this lecture. That's why you can use this next for future also. The first one is boiler. Okay, what is boiler? So boiler is basically where we make water to steam. Basically steam power plant, now every power plant has its fuel. Okay, now the steam power plant, the steam power plant, the main thing is steam. So what is steam? Steam is just the gaseous state of water. And what is boiler? From in the boiler we just make water from, make steam from water. We give heat to the water in the boiler, and the water becomes steam. Okay, so the first thing is boiler. The next is turbine. I'm writing. The next is turbine. The next part or the next component is turbine. What is turbine? I already discussed that turbine is a rotational device. A rotational device which rotates. This, when we generate hot steam, hot pressurized steam, this hot steam has a huge power, a kinetic energy, and it flows within the turbine. It gives pressure to the turbine, and the turbine rotates. Okay, so next is turbine. The third one is condenser. The third part is condenser. The condenser is where we condense steam to make water. In the boiler we make steam from water giving heat, and in condenser we convert steam to water. We release the heat and make the steam to water. That is condenser. And one more thing is pump. Pump, we basically use pump to transfer water to boiler. Okay, because we have to continuously supply the water to the boiler. So basically to supply the water to boiler we use pump. So these four things: boiler, turbine, condenser, and pump. These four components of a steam turbine power plant. So now I will describe how this power plant works. Okay, so you see that this is the schematic diagram, not schematic, this is the plant layout. So in the boiler we basically burn fuel, make heat, and using that heat we convert water to steam. And what can be the fuel? The fuel can be coal, the fuel can be natural gas, the fuel can be oil also. It depends on the availability. Suppose in Bangladesh it is natural gas, in Somalia it may be oil, in some area it may be coal. The availability of fuel. Suppose we don't have oil, so we cannot use oil as a fuel. Okay, because we have natural gas availability, so that's why we use natural gas. In India there are so many coal available, so they use coal. So before going there, one more thing is important, that steam power plant it requires water. So that's why we cannot replace or place steam power plant in the Bandhapot. It should be situated near the river where we can get the water from the river. So always remember the steam power plant will be situated near the water sources, because from where we will collect the water to make steam. Okay. One more thing is not shown here. One more thing is not shown here. That's a, should we use water directly from river to a steam power plant? No. You know that it's in rivers water that is not that is polluted with dust, different waste materials, and different ions. So at first there is a huge water treatment plant which is also not shown here. Please don't draw, students, don't draw. Okay. So at first, in the water treatment plant, this river water is been treated. All the waste has been removed. All the ions, a very distilled water has been made in the water treatment plant. So at first, that water is in the boiler. You see that this is the boiler. At first, this water is in the boiler from the river. It should be in the boiler. Then using the coal, you see that the coal, using that coal, the coal is burned and the heat is generated, and from the boiler it becomes high steam. Using that heat, the water absorbs that heat, and using that heat, the water becomes steam. Okay. There are several parts of steam. There are three types of steam: wet steam, dry steam, superheated steam. We'll discuss later in the future classes. But remember, the steam has become to the superheated steam, where the temperature becomes more than 100 degrees Celsius. It becomes 500, 600, 700 degrees Celsius. It's not about 100 degrees Celsius. Okay. So this high amount of temperature of this steam, makes a huge kinetic energy of that steam. So that hot steam then flow in the turbine. Turbine is the rotational device. That steam flow in the turbine. You see, this is the turbine section. This is the turbine section. That turbine is flow within the steam. So one thing is, in the turbine there is a shaft in between, in the middle of the turbine. That shaft is connected with the generator's rotor. That shaft is connected with the generator rotor. So when the turbine moves, the generator rotor also moves. So when the steam flows within the turbine, the steam turbine moves, and it also moves with the generator rotor. So when the rotor rotates, the generator creates the electricity. So that is the main strategy. So when the steam flows within the turbine makes the movement, the rotational movement, and also the generator rotates, and we get electricity from the generator. After flowing that steam, the steam's temperature and pressure becomes less, because the temperature and the pressure is converted to the rotational energy of the turbine. So it becomes less. After that, in the condenser, the steam becomes water. Sorry for my the steam becomes water, and from this water, the condenser, the pump, using pump, we put the water again into the boiler. So it works in the cycle way. Okay, so that is the working principle of steam. So let me give a clear view in the next. So this is the schematic diagram. This is the schematic diagram. You see that there is boiler. The first thing is boiler. The next thing is turbine. The next is condenser, or finally pump. Okay. So there are four main components. In the boiler, the water becomes steam, and it becomes high pressure, high temperature steam. This steam flows to the turbine. The turbine uses this rotational energy, uses this temperature and pressure, and converts into the rotational energy. And from the turbine, it is connected with the rotor, with the generator. This shaft is connected with the generator, so it also moves the generator. So the generator creates electricity. After that, that steam becomes low. low pressure steam or low temperature steam, because it was high pressure steam, high temperature steam. After flowing with the turbine, it becomes low pressure. Now this steam is sent to the condenser, where it becomes water, okay. The condenser is like fridge, like fridge. It releases the heat and becomes the water. So from this water, it goes to the pump. Using that pump, we create pressure and we transfer this water to the boiler one more time. So this cycle continues. So there are four components. So everything I have discussed, whatever it is given in this explanation. So when the question come that explain the working principle of a steam power plant, you will draw this diagram, the schematic diagram, not this diagram. This is very tough diagram. You will not draw this diagram. You will draw this schematic diagram, and then you will explain the working principle. Okay. So the next thing is, what is boiler? I already discussed, sir, what is boiler. The boiler is nothing, a steam generator or a closed vessel where steam is produced from water. From the combustion, from the burning of the fuel, the steam is produced. This is boiler. Boiler is nothing but a closed vessel where we use the heat by combustion of fuel, by burning the fuel, and use that heat, and water absorbs that heat and becomes steam, the gaseous state of water. Next we will discuss some of the essentials, some of the characteristics of good boiler. Good boiler. You see that the first characteristics is produce maximum quantity of steam. Definitely a boiler should produce the maximum quantity of steam using minimum fuel. That is the main thing, very less using, minimum use, maximum output. Minimum input, maximum output. That is a good characteristics. The next thing is that it should be economical to install. Economical means less money required or less amount required to install. If it is very hard to install, it is not a good boiler. So it should be very economical to install. The third one is it should rapidly meet up the fluctuation of load. The fluctuation of load means demand. When it is high demand, we require high amount of steam, so the boiler should produce high amount of steam. When it is less demand, the boiler should produce less steam. More steam, more electricity; less steam, less electricity. So the boiler should have that facility. It should be capable of quick starting. The boiler should be stable to quick starting. That means, suppose we want to produce electricity after 1 hour. If the boiler produce steam after 3 hours, it will not serve our purpose. So it should be quick starting. Quick starting. We start and then we get the steam properly. It should be light in weight, very light, very less weight, and should occupy less space. Very less space it should occupy. So these are the characteristics of a good boiler. I'm not explaining very much because it's very easy thing, you can understand. Next and last topic we'll discuss, that is the classification of boiler. Sir, how many types of boiler available? There are two types of boiler. One is water tube boiler, next is fire tube boiler. Okay, water tube boiler and fire tube boiler. So water tube boiler, you can identify the types from the name. Water tube boiler, that means water in the tube. Basically there is a closed vessel, and in between there are so many pipes, so many tube available, and in this within the tube there is water available. So in the water tube boiler, water flows inside the tube and outside the fire flows. But in the fire tube boiler, the fire, basically fire means hot gas, hot air gas, flows inside the tube and water outside the tube. Okay, water tube boiler, tube inside the water. Fire tube boiler, fire inside the water, inside the tube. Okay, so you can understand the definition from its name, water tube boiler. So means water inside the tube. Fire tube boiler, fire inside the tube. So let's see the diagram so you can understand. So I think you can see the diagram from here. I think you can see the diagram. You see from this is water tube boiler. You know, this is the whole closed vessel, and this is the tube. These are the tubes. You see that tubes, inside the tubes there is water, and outside that is hot gas. Basically, from the outside the air is sucked, and that air is burned with the hot, either coal, either oil, either gas, and made very high temperature. So this high temperature of hot gas, hot flue gas, flows within the pipe or within the tube, within the pipe or within the tube. So we all know that from hot body, from hot material, the heat transfer goes to the cold body. Okay, so the outside is the hot, inside the water has the less temperature, so the water absorbs that heat energy from the outside and becomes steam. Okay, that is water tube boiler. And this is fire tube boiler. The closed vessel is full of water. The closed vessel is full of water. You see that? And that there are tubes available. Inside the tube the hot gas flowing, inside the tube the hot gas flowing from here, the hot gas flowing, and the outside the water. So we know that the hot body to cold body, the water flow, the heat flows. So the water will absorb that heat flowing within the tube and become steam. Okay, so you see that in the fire water tube boiler, water in the tube; in the fire tube boiler, fire in the tube. Fire means hot gas. Basically what happens, the from the air it is sucked and becomes, burned with the fuel, and it becomes hot flue gas. So that is called fire. Not fire, exact, not fire. Fire is not flowing. Basically the hot gas is flowing. Okay, so next, the difference between the water tube boiler and the fire tube boiler, the most important topic, the difference between the water tube boiler and the fire tube boiler. Okay, as we already know, that in the water tube boiler, water circulates inside the tube. Inside the tube the water circulates, and outside the surrounded by hot gas. Okay, it is water tube boiler. But in the fire tube boiler, hot flue gas inside the tube, surrounded by water. Okay, next is, so it is done, first one is done. Next is the water tube boiler. As you know that the amount of hot gas available in the water tube boiler is more, the amount of water is less in the water tube boiler, the more fire, that means more heat. So it can generate steam at high pressure. It can generate steam at high pressure, and steam generation rate is also very high, and the efficiency will be also very high. More amount of steam will be there. So you see that it generates steam at a higher pressure. But in the fire tube boiler, the amount of water is more, the amount of hot gas is not enough, so it generates steam comparatively at a low pressure. The third one, the steam generation is also high. I said that, the amount of steam, amount of hot gas is higher, so the steam generation will be, much more quicker. And in the fire tube boiler, the steam generation is a little bit lower. The overall efficiency of the fire tube water tube boiler is higher, that is 90%, and the efficiency of the fire tube boiler is 75% on a standard size. The operating cost is high because because the whole vessel should withstand the amount of heat, because in the whole closed vessel it is full of hot gas, so the material required to build that closed vessel should be, very high quality. So that's why the operating cost is very high. But the fire tube boiler, the closed vessel, it should be surrounded by water. That's why it should not, made with such kind of material, so it is the operating cost is low. The bursting chance are more. That means that as there are full of hot flue gas available in the water tube boiler, that's why there's a huge amount of hotness, huge amount of temperature, huge amount of heat available. So the bursting chance, to explode, the explode chance is much more in the water tube boiler. And the but it is less in the fire tube boiler. So as you know that the steam generation is higher, that we can it can generate steam at a higher pressure also. The water tube boiler is basically used for large power plant, but for a small or medium types of power plant, the fire tube boiler is basically used. So these are the difference or comparison between the water tube boiler and the fire tube boiler. These are the boiler terms which we can study, no problem, but it's not required right now. So the main two thing was the working principle of steam turbine power plant, the comparison between the water tube boiler and the fire tube boiler, and also the characteristics of a good boiler. So that was the today's class. I was in a hurry because of your next class will start also, so I didn't taken so much time, but still if you have any question